Alright guys, so now we are going to talk about the section 5.5, exponential and logarithmic equations and inequalities. You are going to try basically to apply what you have learned in the previous sections. When we are having the example number 1, let's take a look at the example number 1 and let me zoom a little bit more. As you can see in this example number 1, if I had to compare this 5 to the x equal 9 to a 5 to the x or 25 to the x equal 125, the main difference is when you're looking at 25 to the x equal 125, you can work out each base. Base 25 could be 5 square to the x, and 125 could be 5 cube. Okay? And because you can work out each base, you realize that using the rule of exponent, you are going to end up to have a 5 to the 2x equal 5 cube. And now your logarithmic property, because you can see that you have the same base right here. And because you have the same base, you can end up to say, hey, now I can write is 2x equal 3, and so x equal 3 over 2. The problem is that with the equation 5 to the x equal 9, you can't do that because there is no way you can transform your 5 and a 9 into the same base. So you're going to take the log both sides, and usually you are going to take log base 10. Okay? Alright? And then you are going to use your log property, and for that means the x is going to be in the front of your log right here. You divide by log base 10 of 5 both sides, and you end up to have the value of x that you will find with your calculator. Alright? You are going to do exactly the same thing with this example number 2. Again, we can't transform the 7 and the 10 into the same base. So what we are going to do is we are going to take the log both sides. We are going to use your log property, okay, on each side of your equation. And then we are going to isolate x by distributing the log, okay, let me on inside of each parenthesis, then combining the x together to have an expression of x. I would like to remind you that in this case, when you have log base 10 of 10, you know that it's equal to 1. So was it necessary to distribute this log base 10 of 10? No, because that is equal to 1. Okay? All right. In the example number 3, it is again the same thing, same idea. I'm going to take the log both sides, and then I'm going to distribute my x. I'm going to use my log property to put my x in the front and divide by log base 10 of 2 both sides to have an approximate value of your x. All right. Let's try to do the example number 4 now. First of all, let me tell you that in this example number 4, the way it is written, it's not a plus 1, it is a minus 1 right here. Right there we're having a minus 1, and right there we're having a minus 5. Okay? That said, what I'm going to do is use the log property, saying that the log base 10 of a plus log base 10 of b equal log base 10 of a plus b, a times b, sorry, a times b, okay? So I'm going to, whatever the base I am, so right now I'm in log base 2, so I'm going to have a log base 2 of x minus 1, x minus 1 times x minus 5 equal log base 2 of 4x minus 1. That right away tell me that x minus 1 by x minus 5 equal 4x minus 1. So I'm going to distribute x by x, give me x squared minus 5x minus x plus 5 equal 4x minus 1. X squared minus 6x plus 5 equal 4x minus 1. I'm going to subtract 4x and add 1 both sides. I'm going to subtract 4x and add 1 both sides. And when I do that, I end up to have a quadratic equation, x squared minus 10x plus 6 equals 0. To solve the quadratic equation, I'm going to use the quadratic formula, which is saying that b minus b over 2a plus or minus square root of b squared minus 4ac divided by 2a. So by making sure I'm not making any mistake on the value of a, b, and c, I'm going to put a plus, and now I know that a equal 1, b equal negative 10, and c equal plus 6. So far so good, because now I just need to substitute the value of a, b, and c inside my quadratic formula, which is minus 10, negative 10, divided by 2 times 1, so divided by 2 times 1, plus or minus the square root of negative 10 squared, minus 4 times a, which is 1 times 6, divided by 2 by 1. So far, so good, because now x equals 10 divided by 2, which is going to be right away, I'm going to write that right away, I'm going to have 5, plus or minus the square root of 100 minus 24 divided by 2. So x equal 5 plus or minus the square root of 66 actually, 76. It is 76. So 76 divided by 2. So x is going to be equal to around, let me do the calculation for you guys, 935.88, or x is going to be equal to, so 5 plus, open parentheses, 5 plus the square root of 76 divided by 2. It's not a plus, it's a minus for the second. It's 0.6411. 0.6411. Now guys, don't look at this right here. There is a mistake on this part. So actually there is a mistake just at the end right there. I don't know what happened. I will make a change later on during the semester, and we do the video if I have time. Now let's take a look at the example number 5 to see if there is not other mistake. Alright, so first of all I'm going to use on the example number 5 the property saying that log of a minus log of b, log base 10, of course, every time, equal log of a divided by b. So I'm supposed to have log of x, log base 3 of x to the x minus 1 equal 1. We're good to go. Using my definition, I can definitely say that that is correct, that is okay, that is a check. And so once I'm done with that, I need to solve a rational equation. And when you have to solve an equation with a denominator, first of all, you are to multiply by a LCD. In that case, the LCD is x minus 1 because there is only two denominator, the 1 right here and the x minus 1, so the LCD is going to be x minus 1. Multiplying by the LCD, the denominator on the right side of my equation disappear. And once the denominator on the right side of my equation disappear, I think it's pretty easy and obvious that now you need to solve for x. So you need to have all the x on one side of the equation and all the non-variable on the other side. Okay? Same idea right here for the example number 6. So now, let's jump on the example number 1, page 4. And we have to rewrite that using your log. So what I'm going to do is pretty simple. I'm going to use a log base 10, and I'm going to say that log base 10 of 7 to the x equal log base 10 of 12. Using my rule, my log property, I'm going to write x log of 7 equal log 12, and so x equal log 12 divided by log 7. Same idea right here. We multiplying by log both sides, so we end up to have a log. We end up to have a log to the 2, 3x plus 1. I like to use my parentheses, equal log to the 3 to the 4 minus x. Now I can put 3x plus 1 in front of my log using my parentheses. This is very important to use the parentheses of 2 equal 4 minus x log of 3. I'm going to distribute 3x log 2 plus log 2 equal 4 log 3 minus x log 3. I'm going to add, let me use another color, I'm going to add x log 3 both sides, and I'm going to get rid of the log 2 both sides. Why? Because by doing so, now on the left side I have only the variable x, and on the other side I have the non-variable. So I can tell that I have, and I forgot to write the 2 right here, I can tell that I have a 4x log base 10 of 2 equal a 3 log base 10 of 3, and so x is going to be equal to 3 log 3 over 4 log 2. Why? Because I need to divide by 4 both sides as well as by log 2. So I need to divide by 4 as well as by log 2 to get rid of the log 2 on the left side and to get rid of the 4, and now having my x standing by itself. I will let you do the example number 3 as well as the example number 4. I'm going to do for you the example number 5. Actually, I'm going to do the example number 4, and I will let you do the example number 5. So if I want to do the example number 4, the first thing I want to do is solve 6x equal 8, 6 to the x equal 8, I'm sorry. And if I do that, I end up to have a log 6x equal log 8. Then I'm going to have is a x log 6 equal log 8. And so x equal log 8 divided by log 6. Once you have the expression of your x, you are going to make a number line, and then you are going to say, okay, x0 is right here. What is the value of x? So let me take the calculator. So x is about 1.1605. So I know that 1.16 is on the right side, so I have two intervals. So I'm going to look at the interval number 1, and I'm going to say if x equals 0, what do I have? I got 6 to the 0. Is it less than 8? Is that less than 8? And 6 to the 0 equal 1. So 1 is less than 8. So the interval number 1 minus infinity and then 1.16 is okay. Okay, it's okay. That I'm going to stay. It's good. If I take x equal 2, I'm going to have a 6 square. Is it less than 8? No, obviously 36 is not less than 8. So I know now my interval notation is going to be negative infinity and 1.6 in between parentheses. Now, guys, I'm going to let you do the example number 5, as well as the example number 6, 7, and 8. Same idea, slowly but surely, and you will be able to do this example together. All right? Let me do the example number 10 with you. And actually, because my video can't be no longer than 50 minutes, I'm going to do the example number 10 in another video. And as well as the example number 11, I guess. No, I will let you do the example number 11. So I'm going to do the example number 10 in another video. Thank you very much, and talk to you in class.